Hello everyone, this is Indradeep Kumar, Assistant Professor, IARE, Hyderabad. In this video, we will see the next, as I told you earlier in previous video, that we will see all the end conditions. So in this video, we will see column with one in fixed and the other free. Okay. So now lecture topic will be the two. We will see the two types in this video. First one is column with one in fixed and the other free, and second column with both in condition. So let's see first column with one in fixed and the other free. Okay, consider a column AB of length L fixed at A and free at B. So let's see, this is fixed at A and free at B. So this is the initial, it should be right at B, carrying a critical load at B. So at B only the critical load is acting. So once load will act, after that it's got buckled. So now that beam is here. As a result of loading, let the beam deflects into a curve from AX1 is a subscript A1 B1. So here, right, AX1 B1, such that the free end B deflects through a distance A. So this will deflect by a distance A and occupies a new position B1. So now it is occupying a new position B1 as shown in figure. Now what is the same, just like previous, take any section. So now consider any section X at a distance X from at a distance small x from A. So here our X is the cross section, that part where we are finding at a distance small x. Now next, what is that? Let P is equals to what? Critical load on the column, and Y deflection of the column at that section, that is at X. Okay, so now what we have to do, we have to find here the moment. So now let's see, here moment is A, and here what we assume that as Y, here it's written. So this is Y. So moment will be totally what? This will be just here, this is convex outward, so that is positive. So plus P into A minus Y. So this is A, this is Y. So total is A minus Y, right? Just multiply. So PA minus PY, okay, plus this here, plus sign due to convexity towards initial center of line. So now this is the moment equation. Next, what is that? Moment equation is, that moment equation is EI d2y by dx square equals to m. So after putting the value of m, what will we get? EI d2y by dx square equals to P into A minus PY, just this one, right? Now take this Y, because this is the variable here Y. So just see, P and A both are constant. So take this to this side. So now this becomes what? EI d2y by dx square plus Py is equals to P by A. Earlier also I mentioned that for differential equation, the coefficient of d2y by dx square should be 1. Means what we have to do? Divide by Pi to the each term. So after dividing with this term EI, it will get cancelled here by EI by EI. So after this, we will get this equation, d2y by dx square plus P by EI into Y equals to PA by EI. Okay, so this is the term. Now in previous we had seen that this side is equals to 0 was there, right? So just see, if this term is there, then what will be the differential equation, that solution of this differential equation. In previous we got this same, right? This is only different this time. Earlier this was 0. So for this solution will be what? Just here, P by EI, and P by EI is here, right? So P by EI won't be there. Remaining whatever is there, that will be the added in that equation. Same equation, just that value will be added. So just see, after removing P by EI, what is left? Only A. So that is plus A. So general solution, this was for the previous one also, right? And because right side one term is there, so after removing that E by EI, whatever the will be remaining things will be there, that we have to write. Later we will see also that this value will be different. This will be same in all the cases. Okay. Next, what is the step? That we have to apply the boundary condition. Okay. So same, where A and B are the constant of integration. Now we know that x equals to 0, y equals to 0. See the figure. At x equals to 0, there is no deflection. So y equals to 0. Therefore, A equals to, so after putting here, let's put the value of x and y. So y is 0. So 0 equals to x0. So a cos x, that is x is 0. So 0 into root p by ei plus b sine 0 into root p by ei plus a. Okay. So 0 into this will be 0. So 0 equals to a cos 0 plus sine 0. So b sine 0 plus a. Now sine 0 is 0. 0 into b, so 0. This term will be 0. Now what you have? 0, that is 0 equals to a cos 0 is what? 1. So a into 1 plus a. So from here what we will get? A equals to minus a. Okay. So minus a. Now here differentiating the above equation. So now differentiate this equation. So let's see the differentiation of this equation. Okay. So here you have to apply the differentiation, but in previous question that differentiation was not required because the in condition was there, their slope was not required because both involves hint. But here one hint is fixed, so we have to find the differentiation of that one, and that is only dy by dx is nothing but it's a slope. So just to know, so just see with respect to what x we have to differentiate. So I am differentiating this here. So differentiation of y is dy by dx is equals to, so now just a is constant, so keep a constant. Then cos integration is what? Minus sine, so minus a sine x root p by ei, right? So this is cos x root p by ei, differentiation is minus sine. Now we have to differentiate this inner part, right? X into this one, this is constant, so differentiation of x is 1. So into p by ei, and that is inside the root. So this is differentiation of first. Now similarly differentiation of second will be what? B. Okay. So this is multiplication, not in argument. B sine becomes differentiation of sine theta is cos theta. So cos and theta is here what? X root p by ei. Okay. Into differentiation of this will be what? This term, so root p by ei plus differentiation of a is 0. So 0. So this is the differentiation of this. By simplifying we can write also like minus a root p by ei, okay, into sine x root p by ei, okay, plus b root p by ei into cos x root p by ei. Okay, so this is our dy by dx. Next, another boundary condition just to find this one. So because already we have that x equals to that a equals to minus a. So just see here after putting this what we will get. So this is the dy by dx condition. Now we also know that at x equals to 0, what is happening here? Slope also will be 0 only because this is parallel to the initial line only. So dy by dx equals to 0. So now put value. This we got, that is here. Okay. So now putting what? Dy by dx equals to 0 and x equals to 0. So after putting the here, what we will get? 0 equals to, so 0 equals to minus a root p by ei sine, this in 0 into this will be 0, so 0 plus b root p by ei into cos 0 into this is 0, right? So 0 equals to same minus a p, so sine 0 is what? 0, so 0 into this term will be 0 plus b root p by ei, this is over root, into cos 0 is what? 1. So 1 means what we are getting? 0 equals to b root p by ei. So again we got a similar equation, right? Now next again little consideration, what either b, so a little consideration will show that either b is equal to 0 or p by root ei is equal to 0. Since the load p is not equal to 0, okay, in this thus obvious that b is equals to 0, because if p is 0 then only this term will be 0, right? Because if p is not 0 then it's not 0, and if p is 0 then we are not applying the force, means here then b is 0. Okay, so now we have the value of b as 0, so substitute that one. So now after substituting, what we will get, so see, now b is 0, so 0 into this will be 0, right? So or here in this case, after putting b as 0, this will be 0. So what we will get, simply y equals to a we got as minus a, b as 0. So minus a cos root x into p by ei plus a, this value. Just here, x equals to minus a, this is the value of capital A, cos x root p by ei plus a, right? Now take a common from both, right? So now just see, this was positive, so that's why I just kept first, and this term is minus, right? So just rearrange this, written as here. So a common, 1 minus cos x root p by ei, this is, so that is equals to y. Okay, now next another boundary condition. We also know that when x equals to L, then y is equals to a. Substitute that boundary condition. So now for y equals to a, and this in this equation substitute. So a, this a is already a 1 minus cos L root p by ei for the third boundary condition. Okay, third boundary condition. After this solving, what we will get, right here, or just see first this one itself, just here. So what we have, a minus a cos x root p by ei. Okay, taking account, first I wrote this term, then this term. So a common, 1 minus cos, 1 minus cos x root p by ei. This is equals to what? Y. Next condition is y equals to a, then x equals to L. Put. So y equals to a 1 minus cos, now x is what? L root p by ei. Let's expand, or no need to take common here also, without that also you can do. So a equals to a minus a cos L root p by ei. So from here, this, take this to this side and this to this side. So a cos L root p by ei is equals to what? A minus a, that is 0. Okay, so now a cos L root p by ei is equals to 0, means cos L root p by ei equals to 0. Now the same way we have to use what value of cos is 0. In that term we can apply. So cos L root p by ei is equals to what? Cos pi by 2 is 0. So we have to take what? Least value. So for pi by 2, 3 pi by 2, 5 pi by 2 is odd multiple of pi by 2 will be 0. So here we have to take the least value. So we are taking as pi by 2. So cos pi by 2. So now what we can do? We can remove cos both sides. So L root p by ei is equals to what? Pi by 2. Square both sides. So after squaring both sides, what we will get? L square p by ei equals to pi square by 4. What we have to find? P. So now just cross multiply. So this will get multiply here, and this L square will be here. So P will be equals to what? Pi square ei by 4 L square. So that is here. It's proved. So see, it's again in the same way we can do like previous one, but the thing only you have to remember this solution, right? So this will be common for all. Only whatever the right side equal to that equal to that value will be there. That is, in this equation, equal to whatever will be there, just remove P by EI and add the remaining term. In first case, that was 0, so that's why we didn't add it anything. So let's see. Recall once again. So one end is fixed, another one is free. So after applying load, what happens? This will buckle, and now this bend will be here. For that we have to find. So we assumed what? At a distance small x, deflection is y, and because of loading, this got shifted by a distance. So we have to find first moment. Once we have the moment, apply the bending moment equation, then take y term one side and just integrate that general solution. So this moment will be what? PA into a minus y. After simplifying this one, so put the value of m here, right, and take p y term to this side. Next, this coefficient of d2y by dx square should be equals to 1. So just divide by ei to all the terms. So after dividing, what you will get? D square y by dx square plus p by ei into y equals to pa by ei. So this we got. Now here just see, whatever this term is extra than p by ei. So just remove p by ei and add this term with the general solution of the first question. So here is the general solution, right? So this term will be common for all, only that a will be added. Now what you have to do? Apply the boundary condition, see the diagram. At x equals to 0 what happened, at x equals to L what happened, and just substitute the value and find the value of a and b, and from there you have to find the solution. So after putting here x equals to 0, y equals to 0, what we got? Dy by dx equals to this one. Sorry, after putting x equals to 0, y equals to 0, we got e equals to minus a. So now we have value of a. Now we require to find the value of b. So what we will do? We will differentiate this equation with respect to x. After differentiating, you got this one. Next, again from the figure, at x equals to 0, the slope will be 0. So just put that value. So dy by dx equals to 0, and wherever here x is there, put 0. You will get 0 equals to b root p by ei. Now in this case, what happened? If either b will be 0 or this term will be 0, but p cannot be 0, right? If p will be 0, means that question itself is not valid. So here means what? B will be, means P is 0 means what? We are not applying any load, and because of no applying load means there is no buckling. So P cannot be 0 means what? Next is only B. So hence B is 0. So once we have the value of A and B, substitute. A is minus A, B is 0. So this whole term becomes 0. So now what is left? Y equals to minus A cos x root P by EI plus this A term. Right? Here, this A term. Right? Just rearrange, write A first, or you can simply take this itself. Now, here, what is required? Just see here. So, now another condition. When x equals to L, that is another boundary condition. When x equals to L, y equals to A. Either you can substitute here itself, or you can further simplify and then you can substitute. So, after substituting y equals to A and x equals to L, we got this equation. Simplify it. So after multiplying, this will be what? A equals to A minus A cos this one. So A will get cancelled. Cos of L root P by EI is equals to 0. For what value of cos is 0, we have to take the list value. So cos pi by 2, 3 pi by 2, 5 pi by 2, so on will be 0. But we have to take the list value. So this one, right? So L root P by EI equals to this. Now both sides cos will get removed. So L root P by EI equals to pi by 2. Square both sides. So after squaring, what will be there? L square into P by EI equals to pi square by 4. Now just divide by L square. So P equals to pi square EI by 4 L square. So this is the load is acting on that one. So this is the second case. Now we will see the third case. Okay. So now column with both end fixed. Now just see here, both end fixed means here movement will also act, right? For the both end fixed, because this one is not rotating, so that's why movement is act. So at this level, the anti-clockwise movement will act, and at this point, the clockwise movement will act, and hence this will remains balanced. So now just see, in previous case also we had seen at the fixed end, it's not getting buckled, it's moving, and that's why here we have taken that dy by dx as 0. So means in this case, what happened at both this end also fixed, this is also fixed. So diagram will be same from both the end up to this. You can say half portion, and similarly for just take this as this side fixed and this part is free. So this part. So this is the combine of those two. Now for this we have to find. Method is same for this also. What is that? Next again same. Consider a column AB of length L. So just these things is very important. You have to write. You have to write everything in this diagram, whatever is there. Okay. So that you have to, because what you assume, nothing is given. That whatever is given or what you assume, that you have to mention clearly. So that's why in every derivation I am mentioning these things. So consider a column AB of length L. Okay, from here to here, length is L, fixed at both of its end A and B. So it's a fixed at A and B, and carrying a critical load at P. Now this is carrying a critical load at P. At B. As a result of loading, let the column deflects as shown in figure. So because of this loading, column will get deflect like this. Let P equals to critical load on the column that is acting on Y is deflection of the column at section X. So at X, at a distance small x, the deflection is Y. Okay, so that is there. Now what we have to do, a little consideration will show that since both the ends of the beam AB are fixed and it is carrying a load, therefore there will be some fixed in moment A and B. So at this A and B, the fixed moment will be there. That is only, let's M naught is the fixed in the moment at A and B. So M naught is some moment is acting at that point, means at the fixed moment. So just what we do, we assume M naught as a fixed moment at A and B. So now overall moment will be what? So this is positive, and the CI, it's making concave one. So concave is minus Py. So moment due to critical load P is Pm equals to minus Py. Because of this load, it's bending in concave form. So total moment will be what? M naught plus M. But so total moment will be M naught plus, M plus M naught, or M naught plus M. So what is M? Minus Py. So this will be M naught minus Py will be the total moment. Now come to the bending equation, right? So EI d2y by dx square equals to M naught minus Py, this total moment value, right? Because this is the total moment. Now next again take this to this side. So after this, EI d2y by dx square plus Py equals to M naught. Okay. Now, so here d2y by dx square, because again what? That coefficient should be 1. So d2y by dx square coefficient should be 1. So divide EI to all the terms. So after dividing EI, this EI will get cancelled. M naught by EI, P by EI. So P by EI by M naught by EI. Let's see, in this video also I told you here how to find. So whatever after A, P by EI you have to remove, right? Other than P by EI, that you have to write. But here P by EI is not there. So just see, here P by EI is not there. So for this what we will do? First we will multiply and divide. Now this P by EI can we remove? So what is left? M naught by P. So what we have to do? We have to add M naught by P. Okay. So general solution will be again same. The term will be added. Yes, M naught by P, because P by EI we have to take the common, that we have to remove. Why? Because in general solution you can see, just see here, this P by EI is there. Okay. So now again general solution will be what? Y equals to A cos X root. So this term will be same for all. Only this you have to take care, and that also whatever the right side is there, in that P by EI remove, and remaining thing just write it. Okay. So now again same, where A and B are the constant of integration. So this also you have to write, because without mentioning you cannot use that one. What is A and B? So you have to write, and then you have to find that A and B, and then finally you have to substitute. Okay. Next, again boundary condition or end condition, right? So we know that when x equals to 0, y equals to 0. See the diagram. At x equals to 0, definitely y equals to 0. Second will be what? At x equals to L, again y equals to 0. And third one is the same differentiation type. So after putting x equals to 0, y equals to 0, put here. So y is 0 equals to a cos x root p by ei plus b sin x root p by ei, right, plus m naught by p. But what is the x equals to 0? So put here x equals to 0. Here also x equals to 0. So 0 equals to a cos 0 into this will be 0 plus b sin 0 into this is 0. So sin 0 plus m naught by p. Sin 0 is what? 0. So 0 into this whole term will be 0. From here what we will get? Cos 0 is 1. So 0 equals to a into 1, that is a, plus m naught by p. So from here what we will get? A equals to minus m naught by p. So now we have a, m naught by p. Next step, what? Differentiate again. Similarly like previous one. So differentiate the above equation. After differentiating what we will get? Dy by same differentiation will be there, like what we got earlier. So dy by dx equals to, because this term is constant, after differentiating that will be 0. Earlier also that a becomes 0. So dy by dx equals to minus a root p by ei sin x root p by ei plus b root p by ei cos x root p by ei. So this differentiation I already showed you in this video itself. So you can just see that one. Now again we have to use what? The boundary condition. So what is boundary condition? Just x equals to 0, then dy by dx equals to 0. That concept is to substitute here. So after putting dy by dx equals to 0 here, so 0 equals to minus a, okay, root p by ei sin 0 into root p by ei plus b p by ei into cos 0 into root p by ei. So sin 0 into this one, 0. So that we can write minus a root p by ei into sin 0. Sin 0 is 0. Right? So this term will be 0 plus b root p by ei cos 0 into this is 0. So cos 0 is 1. So 1. From here what we will get? 0 equals to, this term will be 0 because multiplying by 0. So b root p by ei. So yeah, we got b root p by ei. Again, what is required? Little consideration is required. So what will be that? Just here. A little consideration will show that either p is equal to 0 or root p by ei equals to 0. Since the root p cannot be equal to 0, already we had seen in the previous derivation also, means b is 0. Okay. So now that thus b is equals to 0. Substituting the value of m, here it's a equals to minus m naught by p. Now substitute value of a and b in general solution. So after putting what you will get? Okay. So now I am substituting a and b value in equation 1. So let's see what we will get. So a value what we got? Minus m naught by p. So y equals to minus m naught by p, cos x root p by ei plus b 0. So b into 0, 0. So I'm not writing that one. And what is left? M naught by p. So this is the y equation. This is the y equation. Okay. Now similarly earlier a was there. So what we did? A naught, a common. So same here, take m naught by p common. So after taking m naught by p, what we will get? M naught by p into 1 minus cos L root p by ei. Okay. So from here what you will get? Just here. Again, if you will multiply, then just here, I am just expanding this one first. So 0 equals to, multiplying this, m naught by p into 1. So m naught by p minus m naught by p cos L root. So just here, another boundary condition in this we have to substitute. What is that? X equals to L and y equals to 0. So substitute y equals to 0 and x as L. And after that, Next, just multiply this term. So L root P by EI. Okay. So now take this side, this term to this side. So M naught by P cos L root P by EI is equals to M naught by P. So this M naught by P cancel, or you can just take this side, divide. So now what we will get? Cos L root P by EI is equals to what? 1. Which value of cos is 1? So cos 0, cos 2 pi, cos 4 pi. That is multiple of 2 pi will be the, or you can say that even multiple of pi will be 1. So what we can write for this one? So again, here we can write cos L root P by EI equals to what? Cos, because we least significant we have to take. So cos 2 pi. So now we can remove cos both sides. So L root P by EI is equals to 2 pi. Now same step, square both sides. So squaring both sides, what we will get? L square P by EI equals to 4 pi square. So from here P equals to what? 4 pi square EI by L square. So this will be the final P. This, in terms of that also we can write like this: P equals to this, because numerator in all pi square by EI we got. So just I am writing in that form. So pi square EI by L by 2 whole square. L square by 4, this 4 here. So L square by 4, that I am writing as L by 2 whole square. So this also you can write here same, which is equals to pi square EI by L by 2 whole square. I will tell you later why I wrote like this when we will see the column, Euler's equivalent length, that equivalent. Course in that case we will just compare all the conditions with one single value. There we can replace the crippling load or that Euler length value according to this one. So that we will see in later, right? So in next video we will see that one only. So see, again I am recalling quickly the same, this derivation. So only thing is the moment is required and the general solution is required. So let's see here. Okay, so here both side is fixed. That's why here one what fixed in moment is acting. What we assume that as m naught. So m naught, and because of this load, what is the moment? Minus py, because it's a concave. So total moment will be what? M naught minus pi. Now apply the boundary that means bending moment equation. Ei d2 by dx square equals to moment. So moment is m naught minus py. Take this py to that side. Then you will get what? Ei d2 by dx square plus py equals to m naught. Okay. Now divide by ei to all the terms. Why? Because coefficient of this should be unity. So after dividing by ei, what you will get? d2y by dx square plus p by ei into y equals to m naught by ei. Now here you have to just see how easily you can, no need to remember that formula. Which one? General solution. How you will remember? One only you have to remember, that is common for all. That solution of the general equation, that is this part, we can see it's a common to all. So means that part will be same here only. The difference is earlier also I told you what? P by EI you have to remove. That you have to ignore P by EI, and whatever the remaining thing you can take. But here P is not there. Means we have to introduce the P. How? So after multiply, P divide P. So now this P by EI you can remove. What is left? M naught by P. So just add m naught by P. Okay. So after adding this, we got the general solution. Now after general solution, what you have to do? Just apply the boundary condition. So first boundary condition is what? At x equals to 0, y equals to 0. Substitute the value. After substituting the value, what happened? This term will be 0 because sign is there. So here this term will be 0 because sign is there. And after putting 0, this will be 1. So a equals to minus p minus m naught by p will get. So a equals to minus m naught by p. Next step, what is that? Differentiate it, because at x equals to 0 slope is 0. So that for that we are differentiating this one. So after differentiating, same like previous, we will get this one. Now next, which one? Apply boundary condition. So at x equals to 0, dy by dx equals to 0. Substitute these two values here, you will get 0 equals to b root p by ei. Now here either b will be 0 or p will be 0 because ei is constant, ei cannot be 0. Right? So b cannot be 0. If p is 0 means there is no force acting on that one. So p is not 0. Means b is 0. So now we have value of a which is here and b. Substitute the value of a and b here. So this is a equals to minus m naught by p and 0. So after putting that value in equation, which one? General solution in this one. Equation 1. Okay. So we got this one, minus value of a is minus m naught by p, cos and b is 0. So b total term 0 and m naught by p. Take m naught common, 1 minus cos root l by pi. Now third boundary condition, at x equals to l, y equals to 0. Just substitute. So at x equals to l, y equals to 0. So y is 0, m naught by p, 1 minus, now x becomes l root p by ei. After simplifying, just multiply this one, take this negative part that side and then divide by m naught p. That m naught p will get cancelled. So after this, you will get cos l root p by ei equals to 1. For 1, cos is either 0, 2 pi, 4 pi, right? But least significant value we require. So means cos 2 pi. So this cos L root p by E equals to cos 2 py, and hence now we can remove the cos. So L root p by E equals to 2 pi. Squaring both sides. So this will be L square root p by E equals to 4 pi square. After finding p, that p will be equals to 4 pi square ei by L square. Okay. So again, this derivation you can find in the strength of material book, name is there, written by R.S. Khurmi, and that you will get this. So if you have any doubt, you can just comment on the video. I will clarify that doubt. Okay. And thank you.
Like, share and subscribe. Hit the bell icon for more updates.